Hello, students. I hope you will be fine at home. Uh, in the previous lecture, actually, we lot of talk about the theory of errors, and there's a subject that is power system instrumentation. And as per our curriculum, it is in the fifth semester, means third year, and the code is 311. First of all, as I earlier told you, the power system instrumentation. It means we are talking about the measuring thing, means measurement. The instrumentation comes from the measurement word, and the measurement is very necessary nowadays. And we can say, if we don't know the measurement, how can we build a thing? How can we do a thing if we don't know about the measurement? For example, if I want to make a one room in my home, if I don't know that how much amount of cement, how much amount of concrete, how much amount of the raw material I have to purchase, and in how much quantity I have to purchase, so I can't able to basically do the work very easy, in very ease, or we can say in the manner of ease, or very easily. So first of all, I need some measurements. If I want to make something, I want to cook something, so there will be some measurements there. If I want to make a cake, so I need a cocoa powder, I need a milk, I need we can say chocolate, something, I need a egg or whatever. So I need some measurement, that how much amount I need it. So measurement is there. So similar to that one, in power system, we have to measure so many things. For example, we have to measure the basically the quantity. Quantity means how much voltage you have to transfer from one circuit to another, and how much in which frequency, in which range of frequency we have to work. As for our India, we have to work in 50 hertz. Okay, but this is for the electrical. But if I have to talk about the electronics, so we work in the gigahertz, kilohertz to some gigahertz frequency we have to work for communication. So there will be some certain ranges. Okay, and the measurement also there. For example, all of you listen the FM. Okay, FM is an example, but what is it? Is basically the full form is frequency modulation. We use in the radio. In the previous manner, we use in the radio, but in FM there are so many channels, and their channels having some reading, that 98.3, 95.3, 98.3, 104 point something, 101 point something. So these are some ranges, means some measurement is there, that we have to fix our basically range to this, then we are getting the good signals through our antenna, our FM receiver system. So that is the ranges, and these ranges basically come in the measurement, because we know the how much measurement we have to do. We have to fix that needle to that frequency range. We have to scan at that frequency range. So this is basically deal with the power system instrumentation, similar to that, because in power system instrumentation we have to measure the things. We have to basically take the measurement, and through if I am taking the measurement, so I need a instrument to measure that one. Okay, so that is the instrumentation, and we are using this in the power system, so that comes in the power system instrumentation. So in my previous lectures, I already told you about the brief, that brief and in the elaborative manner, that if I want to measure something, though I have to know the about the errors which is present in that one, losses, we can say in another way, that I know that understand I can understand, or I can basically eat for 200 kilocalorie daily. Okay, 200 kilocalorie or 200 calories daily. So it is fixed for me. If I eat 250, some effect will be there. If I eat only 100, then again some effect will be there. So the measurement is there with us. So I have to identify what are the errors we have. For example, we anyone ask you about what are your weaknesses and what are your strengths, what are your strength and what are your weaknesses. So strength is the power, but weakness is error, because if you will get very angry very soon, so that is your weakness. And you are very impatient person, you are very we can say impatient is there, you are a very boastful person, talk a lot. So that is why we can think about it, that these are the errors for you. So what we have to do, we have to try to eliminate these errors. First identify the cause, and first identify that how many, which type of error do you have. So first identify the errors. So that is the, in our unit number 1 is basically deals with the errors, types of error. Now if I am talking about types of error, so we're having so many types of error. For example, we having instrumental error, we having environmental error, we having gross error, we having random error, we having parallel errors. So these are combinations. Three errors are there mainly, but we having the elaborative means environmental, okay, instrumental, observational. Parallax is the worst form. Environmental, we having some environmental effects, for example pressure, wind, and the, we can say, vibrations. So they basically produce an error in the instrument. So these are the theory of error. So in the previous lectures, basically we have studied about the errors, types of error, how can we eliminate, try to eliminate, and the calculations. How can we calculate them if errors are given to you, if measurements are given to you, that how can we drive the maximum possible nearer value. Nearer value means if I want to calculate that a meter will give you the 5 ampere reading. If I am not getting the 5 ampere, so I'm making precision or making so many readings. For example, I took a6 readings, so what I have to do, take a mean of that one, take a average of that one, then try to take our value nearby that 5. So that is the calculation we have to do. That is dispersion, basically the means dispersion. So from the previous, I have to start our unit new here from that one. That is the theory of errors and the variation, basically the disbursement or dispersion. Now objectives. If I am starting something and you start something, so there will be some motto and objective for you. Now at the end of this lecture, means my lecture, students should be able to what they will first define the standards deviation. What is standard deviation? What is the definition? Merit and demerit of obtaining standard deviation, means merit and demerit. What are the merits, what are the demerits? That if I am using standard deviation, so there will be there should be some merits, the advantages. There should be some disadvantages, why we can use for the certain limit, we can't use for the maximum limit. So that is the demerit. Now what are the merits, why we are not using only mean, we use this deviation, why? Because it gives you the accurate result compared to the mean. Okay, that is. And this I took standard deviation, why? Because the this is the method through which we can calculate the mean, calculate the variance, calculate all these things. That is the standard deviation here. And certain some examples here also for you to calculate the variance and standard deviation, to try to understand that how can I and you calculate the standard deviation. First of all, I want to know, I want to tell you that you know about the standard deviation, maybe because you have already studied in mathematics, that is standard deviation. But here, which type of example we can find? Here we having some measurements. Through that measurements, we can calculate the standard deviation. So the main motto, my objective to deliver this lecture is to know, to tell you about the standard deviation. If standard deviation, you understand about the standard deviation, it means you can easily calculate the measurements value and derive the nearer value. The nearer value means the we can say the value which is nearer to your accurate value, means nearer to accuracy. Means I already took an example before, that is 5 ampere, that you have to measure the 5 ampere in the ammeter current value, but you are not getting the 5 ampere accuracy. You are sometimes you are getting 4.2, 4.3, 4.4. So you took 6 readings. So you have to do what? You have to take mean of it, then deviation, and then find out the deviation, that how much deviation we have, this much. So that is the calculate the variance and standard deviation. So these are the objectives in my lecture, in my today's lecture. Now there are certain terms which must be defined as they form the basis defining the measure of dispersion of data. So in the previous lecture, I told you about the dispersion of data. Now I took a graph, two curves were there. One is the lying the curve between x1 and x2, another lying between x3 and x4. So x2, x1, x2 having some dispersion, means data is not dispersing, means not changing from center value, that is the mean value. But in the second graph, I told you about so many dispersion, means it is changing. Okay, means changing. So the form, the basis defining the measure of dispersion of data. First, the range. Range is what? Range is what? basically the limit. At your limit, your range. Now you have to drive a car for 5 kilometers only in a day. If your range is 5 kilometers, means you start from 0 to 5. That is your range, and 5 to 0. So we can say maximum to minimum limit. We can drive the maximum minus minimum limit. We can drive your range. The deviation, the deviate means you are not at the center value. You are deviate from that. That is deviation. Identify the deviation. Average deviation. That how many deviations you have. Take an average of it. For example, you are having the deviation. For example, 6 deviations. So you have to do what? Calculate all the deviation. Divide by 6. Just like the mean. Okay, now the standard deviation, which I tell you later in this lecture, basically the lecture which is focused on this standard deviation. Then variance is just similar to deviation, but now square root is not there, one thing. So it is similar to that your standard deviation. So basically, what is my motto of today's lecture? To tell you about the standard deviation, because in this unit number 1, the theory of errors, we already know that so many types of error we have, and we can also eliminate these error, and these error can be eliminated by the, first of all, if I want to remove the parallax error, so what we have to do? Careful take readings, careful record the readings. Okay, and if environmental error is there, so always take a measure that you use your instrument in the in the room temperature or whatever it is which is fixed for it. Means, for example, that measuring instrument have to work for 20 degree 25 degree centigrade, then you have to do what? You have to try to make 25 degree every time wherever the measurement you are doing. Okay, so one thing is there, that is that you have to take some precautions to at the time of measurement. So these are the elimination of error. Types of error, how many types of error we having gross error, random error. Okay, the part of it is basically the instrumental, okay, observation, environmental. So we can say these are the errors basically. Okay, so an error are the mistakes which is done by ourselves also. And the thing, now dispersion of measure means we are not getting the accurate value, you are getting the value nearby to the main value, but nearby, not same value. So there will be some precision. We are getting so many readings, that is dispersed basically, we can say in another way. So how can we take measure of it? So first we have to fit the range. The 6 readings are there, 7 readings are there, that you have to work for it. Then deviation, so how many deviations we have? I am not getting 5 value, I am getting the 4.5, 4.6, 4.7, 4.8, 4.9, 4.6 again. So I am getting the deviations. So average of deviation means it's just like a mean. It's just similar to that mean. Means take calculate all the deviations, sum of it, and divide by how many deviations you have. That is the measurement. Okay, standard deviation, it is similar to that. It's having some formula that you have to do, and in this lecture I will tell you how can we do the standard deviation. Now variance is basically the similar one to the standard deviation, but no square root will be there. Okay, now move on to forward. Now what is standard deviation? The lecture which is focus, my today lecture is focus on this thing, the standard deviation. To know all about this standard deviation and how can we solve the numericals using this standard deviation. So I use one or two examples here, two examples for you to do. Okay, and in MCQs we have also these things that you have to identify, you have to calculate these things. Okay, now if I'm talking about the standard deviation measures the dispersion of data. Standard deviation measures the dispersion of data. Basically, why we are using the deviation, standard deviation, how much disperse of data we are having. Means for example, I have to take the readings of 5 ampere in my ammeter, but I am not getting exact 5. I am getting some dispersed value of the data. So what I to do? Take a record of it, do it of it, and measures. So that is the standard deviation measures the dispersion of data. Okay, it shows the average absolute distance of each point from the mean. Mean is the main value. Mean is what? Basically, calculate all the value, divide by the number of measurements, number of values. If I having 6 readings, 7 readings, 8 readings. So, for example, 8 readings are there. In the numerator, calculate all the 8, divide by 8. That is your mean. So, it shows the average absolute distance between the distance of each point from the mean. Means it shows you what? For example, you're having so many readings. For example, you're having 4.2, 4.3, 4.2 again, 4.3 again, 4.4, 4.5, 4.6. And your main value is 4.8. So you're having 4.3, 4.4. So 4.3 means zero point 0.5 is there. 4.4, zero point 0.4 is there. Zero point 0.5, zero point 0.3 is there. 4.6, zero point 0.2 is there. 4.7, zero point 0.1. So that is the distance. So it shows the average absolute distance of each point from the mean. Okay, in this standard deviation we can calculate. The greater the value of standard deviation, the further data tend to be dispersed from the mean. The greater value of standard deviation, now one thing is there, my dear student, if I am getting the greater value of standard deviation here, so greater value of standard deviation, the further data tend to disperse from the mean. So many dispersed thing means we basically disperse from the mean. Okay, the greater value means if I am getting the higher deviation, it means we having the so many dispersed from the mean. Okay, now move forward. What is the merits of standard deviation? What are the merits of standard deviation? So first, it is the most reliable measure of dispersion. Now if I want to identify the dispersion, now one thing you have to understand, my dear student, that dispersion is basically word come from disperse, and disperse we can also say the scattered. If I want to understand one thing, means you are playing a game. For example, you are playing a football, and in football you having all players in the ground, and you put your players with for a group, in a group, to till the goal to the up to the goal of opponent team. Okay, goal of the opponent team. So you make a team. For example, you have persons, you make a team of it. One is your goalkeeper, another one is the player and defender, and some will at the middle space or at the D, so at the goal of the opponent team. So you make a team. But if you make a team and you do that, your team will be work equally, means may in a synchronized manner. But if they are not doing the work in synchronized manner, means they will become unsynchronous. So what will happen? The dispersion is there. They dispersed, basically they scattered to do. So it is the most reliable measure of dispersion. So if I want to measure something, so that is the reliable measure method, or we can say, of dispersion we can calculate. Secondly, it is most widely used measure of dispersion or variability. Now, dispersion or variability. Now, it is very good to try to understand that variability. The variability word is come from variable, and variable, changing, dynamic. Okay, so if tends to change or changing or or variable, though it is most widely measure of dispersion or variability. So it is through this we can widely use what? Widely means we use worldwide, or we use in a very we can say large manner for measurement of dispersion or variable. If I want to measure the variability, so I use this standard deviation method. The word deviation come here. Okay, so that is the good method. These are the merits. Now its computation is based on all the observation. Now one thing is there, my dear student. See, if I am getting the reading, now I want to take the reading 5. What I have to do? I want to take the reading 5. Now I took readings, 5 ampere reading I have to take. Means the accurate value is 5 ampere in my ammeter, in continuation with my previous example. Okay, so in this what happens, I basically did what? I took 8 readings. 6 readings are very good for me. It is near to 5, that is 4.6, 4.6 for 4 times, 4.7 for 2 times, 6 readings. But one reading I make an error. I make an error means I did some error, means due to parallax error I read it only what? 2.5. Now the main reading will be 5. Now I took the half reading, that is 2.5. So that is the error. But we can calculate. So it is the computation is based on all the observations. So one observation is my error. My dear student, I did one error, that is 2.5. That is parallel. That is a form of parallax error in the vision, basically. But I make a mistake. I made a mistake, dear my dear student. So if I have to do, I have to remove this error, or I have to calculate the error. So this method is very good. Its computation is based on all the observations. Understand? Hope you understand. Now, demerits of standard deviation. If I talk about the demerits, so it is relatively difficult to calculate and understand. Why it is relatively difficult? Now in examples I'll show you. In this, what I have to do, my dear student, is in this the calculation is very high. Calculation means I have to calculate so many things. Means I have to take a mean, then range of it, then put in the formula and then calculate. So relatively difficult to calculate is what? First, mean is very easy for us. Mean is what? Basically the average is similar to that your average. In average, what we do? Just put all the values, sum of all the values in the numerator, and divide by the denominator with the number of measurements or number of values. For example, I have 8 values: 2 4 times, 3 3 3 2 times, and 1 1 2 times. So 2 4 times, that is 2 into 4 8, 3 4 2 times, 3 into 2 6, 8 plus 6 14, and 2 for 1 times 14 plus 2, that is 16, and divide by how much reading? 8. So 16 by 8, that is 2. So your reading will be 2, we can say. Okay, but in this standard deviation, we say that the mean is a one part of it. Means not only mean, you have to take a mean. It is compulsory that you have to take mean, but after mean you have to subtract from that mean the actual value, most probable value, then calculation occurs more. So that is why it is relatively difficult to calculate. Means calculation is very much compared to the mean, compared to the average. Calculation is higher. And why it is higher? I gave an example previously. I told you that how can we do it? We can do it with the help of this. So first I have to take the mean, then difference of that mean, and difference of mean, then we have to calculate this mean value and take out the output. So it is difficult for us. Now, it cannot be used for comparing the dispersion of two or more serve series given in different units. So it is very good for the dispersion calculation, but if comparing the dispersion of two or more series given in different unit, means one unit we can easily calculate, two units we can easily calculate. Okay, but if two or more we have, okay, one we can easily calculate series. For example, I have a now see what this line basically tell you. This line means, for example, I have three different readings, set series of different readings. Okay, one for the 5 ampere of that ammeter, one for the 7 ampere for that ammeter, one for the 9 ampere for that ammeter. So for 5 it works separately, for 7 it works separately, for 9 it works separately. But comparing, if I want to do, so it is very difficult and we can't use it. So the meaning is that one. I hope you understand about this line. Let's go through it. I hope you understand this thing. Okay, now it is affected very much by the extreme values. If I have the extreme values, means I can't able to do it or I can't able to solve it. So extreme values is affected very much by the some extreme values. So if I have the extreme values, so it is affected very much by that, by the extreme values. I hope you understand this thing. Now move forward. The formula which we use. Okay. Now standard deviation has a symbol sigma, which we always represent this sigma, this standard deviation with the symbol sigma. Okay. Now, if the data represent a population, sigma, and S is represent a sample. S is represent what, my dear student? Sample, and sigma represent for the population, means higher value. If I'm talking about the sample, then we use the second one formula. If I'm using the for the population, I use the first formula, that is sigma is equals to what? X minus x, the whole square of it upon n, and x minus x the whole square of it n upon n minus 1. The another x is the mean, and x is the mean value. The thing is that. So we are having two formula. Just go through it. Just go through it. See what is written here. Okay, I hope you understand. So for the population, if I want to say that population means more values, more pupils. Population word for the pupils means more, so much readings you have, so many readings you have. So for that so many readings, we use the previous one formula, that is x minus x whole square upon n under root of it. Okay. If I talk about the sample, means one specimen is there, one sample is there, then I use x minus x whole square upon n minus 1. Okay. So I hope you understand about the formula. Now move forward. Now this is the graph. This is the mean. Now this is the standard deviation. We can also say in the negative side. We can also see in the positive side. So try to understand about this graph. In this graph, a Gaussian curve is given to you. The mean value is always called as a standard deviation value. The mean value is what? Is basically what is the mean value here for you, my dear student? The mean value is what? The middle value. We can say the center value. Mean value is what? The center value. Okay, the central value, and the deviation is basically the dispersion. So here we can identify. See in this graph, we having some values. Curve is there. Now this is the center value. We having the mean of it. Okay, then we having the deviation. Standard deviation is here, we can identify. This is also deviation, but this is we can say this in the negative side, it is the reverse side, and this is the positive side, forward side, we can say. So this is how can we identify the standard deviation in the form of graph. The graph is given to, so from this graph we can easily identify that the how standard deviation basically occurs or appear in the curve, if I want to see it or if I want to find it. Okay, now see, if I have the so many values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 here, but in the negative side. In the positive side, we having again 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. These are the limit. This is drawn between the limit. Here we having the negative side, here we having the positive side. So mean will always give you the middle value, that is center value. Okay, now, but if I am talking about the deviation, so deviation is the dispersion, because we having certain values. We are not fixed 10 value we are getting certain values. So first take a dispersion. This is the dispersion, so we have to do what? Calculate it. So the measurement or calculation of standard the dispersion is first mean, then standard deviation. So I hope you understand. Now one example for you. Find the variance and standard deviation of which the the mathematics test scores of 5 students are, means 5 reading are 92, 88, 80, 68, and 52. So we are considering that we having A, B, C, D, E. 5 students are there. A student basically having or scoring 92 number. B student score 88. C student score 80. D student score 68, and E, that is the last student, score 52. So the maximum number we are identifying is 92 or minimum is 52. First thing. Now what we have to calculate, we have to find out the variance. How much variation we have, the variability we have, that is variance, and standard deviation is also there. We have to calculate the standard deviation. Okay. Now move forward. How? The solution. First, find out the mean. So my dear student, if you want to find out the mean, the what we have to do? What you have to do? Tell me. How many scores we have? We have scores of 5 students. A, B, C, D, E. Means 5 students. So first A student score, that is 92. Then B score, that is 88. Student of C score 80. Student of D score, that is 68. Student of E score, that is 52. Now A plus B plus C plus D plus E. Divide by how many students we have? 5. Similar to that one, scores of that. First, we have 5 students. Present as A, B, C, D, E. So addition of these A plus B plus C plus D plus E upon how much? Means n number, that is 5. So 92 plus 88 plus 80 plus 68 plus 52. So we'll get you what? 76 here. What we are getting here? 76. You can also do with your calculator or with your simple calculation is there. 92 plus 88. So what we can say? 92 plus 88 is what? 180. Then 80 plus 80, that is 260. 260 plus 68, that is 328. 328 and 52, that is what? 380. That is what? 380. Okay, we can say that. And divide by 5. So 380 divided by, we're getting 76. So the mean is 76. The average value is 76. So mean value is what? That is your average value basically. Mean value is always called as the average value. Now first step, you have to calculate the mean. Now find the deviation from the mean. Now deviation from the mean is, that is the final value, center value is 76. Now take out the deviation. How much you deviate? The average value will be 76. Now a student scoring what? 92 number. 92 number. So what is the difference between 76 and 92? Just take a difference of it, subtract it. So 92 minus 76 will give you 16. The difference is 16. Now B student 88 score 88, but average is 76. So 88 minus 76, what we are getting? 12. Again C student scored 80 marks, but the average is 76. So 80 minus 76, 4, nearby the average. D student score 68 number. Score how much? 68. 68 minus 76, that is your mean. So you are getting negative minus 8. Negative side means lower than the mean. Your mean value will be 76. So it is negative side to the mean. That is minus 8. Now, the last student, that is we represent as a E. So E student score how much marks? How much score? That is 52. And the average value is 76. So 52 minus 76, that is negative 24. So we can say we deviate from minus 24 to plus 16. Minus 20. If I want to make a curve of it, how can I make? From the negative, the limit is minus 24. So from the positive limit of the deviation is 16. So we can make a graph between 16 to, we can make a graph minus 24 to 16. Okay, understand about the mean, understand about the deviation. Now move forward. Now square the deviation from the mean. First deviation I took as 16. So the square of 16 is 256. The square of the 16 is, my dear student, it is a very simple mathematics. You know about the table of 16. So 16 into 16 we are getting 256. Now the square of 12, 12 into 12, it is very simple, that is 144. Now the square is 416. Square of 8, minus 8 is there but square, so minus minus will become plus, so positive side. So we are getting what? 64. Now minus 24 square, 24 square is 576, and minus square is positive. So square of that mean, square the deviation from the mean. Deviation from the mean, you know. First, what we have calculated, we calculated the C. First we calculated the mean. It is very simple. Add all the numbers, divide by 5, we'll get the mean. That is the central value. Now find out the deviation from the mean. Deviation from the mean is the difference from the mean, central value. So take one by one. First score certain marks, subtract from it. Second subtract from it. Third subtract from it. Fourth subtract from it. Then 5 subtract from it. So you'll get positive and negative both sides. Okay. Now take a square of that deviation. That is here. That is 16 square what? 256. 12 square what? 144. 4 square what? 16. Minus 8 square by 64. 8 means 64. And minus square means plus. So positive 64. Now negative 24, 24 square 576, and negative square will become positive, so 576. Okay, now find the sum of the squares of deviation from the mean. Now you have already calculated the square. Now take a sum of it. Now take a sum of it. So what we have to do? 256 of the first square deviation, second 140 for the second square deviation, 16 is the third square deviation, fourth the square of the deviation, fourth deviation, that is, and 576 the fifth deviation square. So if I add all these five quantity, I am getting 1056. Hope you understand. Okay, now divide by the number of data items to find the variance. Now I have to calculate first variance, then standard deviation. So now I'm coming to the point. That is the solution of first part. Now I'm getting the solution of first part. That is variance. So variance is, how can we calculate? 1056 is total square difference. Divide by how much numbers we have, how much data we have available with us. That is of 5 students. So divide by 5, I will get 211.2. 211.2. Now, second, find the square root of variance. Find the square root of that variance will convert into you the deviation. That is which deviation? Standard deviation. So the difference between standard deviation and variance is what? Variance having no square root, but deviation having the square root of that variance. So we can say the relation between the standard deviation variance is just a square root. Okay, now I'm revising this formula. Now you will getting the value 14.53 is your scores standard deviation. Okay, now see, first what we did, first we having the values, that is the four values, five values we have. Take a mean of it, divide by 5, you'll get 76. Then what we have to do? Take a deviation. So how can we identify the deviation? We can identify the deviation means subtract the deviation from the mean. How much deviation we have means mean is the lower value or higher value. Just subtract one by one with that mean, you'll get the deviation. Now take a square of that deviation. Here it is. I hope you understand. 256 of first, second is to 144, third is 16, fourth is 64, and fifth is 576. Now see, if I'm taking a square of it, means negative side will become positive side. Okay, so negative will always become positive when we are taking square. Okay, now addition of all these deviation squares of deviation, I'm getting the value. Now divide by how much data or how much number of data available with us, that is 5. Divide by 5, you will get the value, that is 211.2, and the basically the square of deviation total is 1056. It is very simple mathematics. You have to just add it. Now after the variance is basically what we can say, the additional square of deviation divided by the number of scores available with, or number of measurement available with you. So 1056 by 5, we are getting 211.2. That is your variance, and the difference between variance and deviation is of just square root. So take a square of it, square root of it, you'll getting the standard deviation. So your answers are 2. The solution first is, the variance value is 211.2. There is no unit. Standard deviation is 14.53. Again, no unit. So I hope you understand how can we calculate the standard deviation and variance. Okay. Now later on move to the forward. Now find the standard derivation or deviation. Sorry, the standard deviation for a population data. That is 64578. So you have how much quantity? 5. Again, 5 data available with you, population, that is 64578. First is 6, another one is 4, then 5, then 7, then 8. I hope you understand this thing. Okay, now 64578. Now see here, first take, we make a table also. We can easily calculate in this manner. How in this manner we can calculate? Just go through it, just see it, my dear student, just see it. And number of quantities we have, how much quantities we have? 5. Now the numbers are given to you in the population, that is 6, 4, 5, 7, 8. So first is 6, another one is 4, then third one is 5, fourth one is 7, fifth one is 8. So x minus x. Okay. Now x is what? Basically x, we can say the bar is there. So first take a mean of it. Take a mean of it. So 6 plus 4 is what? 10. 10 plus 5 is what? 15. 15 plus 7 is 22. 20, 22 plus 8, that is 30. And mean is what? Average is what? Calculation of all the measurement divided by number of measurement. So 22 plus 8, that is 30. Last we have calculated 30 divided by 5, what we are getting? 6. So 6 your x here. X means x bar is here. So x is 6, that is mean. One x is your measured quantity, another x is for the mean. Okay, so mean is 6. So first take deviation, that is what? Deviation is what, my dear student? Deviation is what? Actual value, measured value minus mean value. That is first 6 minus 6, that is 0. Fourth is second is 4, that is actual value, and measure mean value is 6. 4 minus 6, you are getting minus 2. Third value is 5 minus 6, that is again minus 6. Fourth value is 7, higher, minus 6, that is 1. And fifth value is 8, that is minus 6, you are getting 2. Okay, so you are having the value, that is 2. Now take a square of all the values, means that is the deviation. Take a square of the all deviation measurement. So first we have calculated the mean, total numbers divided by how much number we have. Then take a difference of deviation, means deviation from the mean we calculated. Then we take a square of it. So 0 square 0, minus 2 square 4, minus will become plus. 1 square always 1, minus again 1. 1 square again 1. Now here we having 2, we can calculate the value easily. Okay, so here it is 2 become 4. Okay, so it is wrongly written is here 2, so it will be the 4 value. Now 4 is there. Now addition is correct. 4 plus 5 plus 6 plus 2 plus 2, that is 10. So we'll get the 10 value. Understand, we are getting the variance, that is not variance here, that is the square deviation. So that is the 2 value, 10 value. Now 10 is there. Now we have to take the variance. What we have to take? We have to take the variance. So variance is what, my dear student? Divide by how much number we have. How much number we have. Okay, how much number we have. So we have what? 10 divided by 5 will get 2. So variance is 2, but the standard deviation is root 2. So standard deviation will be your root 2. So it is nearby 1.4. You're getting the value 1.4 is the standard deviation. If I talk about the variance, that is 2. So I hope you understand about this thing. That is the simple example which is given to you, that how can we calculate the standard deviation. So if I talk about the measurement here, means error here. So many errors are given to you. You have to do what? You have to basically calculate the errors in this manner, means population manner. Take this formula, make a table and calculate like this. So your answer will be variance is 2 and standard deviation is 1.4. I hope you understand. Now, this is all about my lecture. So this is the summary. Standard deviation measures the dispersion of data. As I earlier told you, if I want to calculate the dispersion mean dispersed value, so this standard deviation is very good method for me, or for the errors also. Okay. Secondly, it is most reliable. It is very reliable. We'll get the we can say the accurate work or nearby value, like near to accuracy value through this standard deviation. The greater the value of standard deviation, the further the data tend to be dispersed from the mean. If I am getting the greater value of standard deviation, that means what? The further the data tend to be dispersed, basically scattered, distance, high distance from the mean. I hope you understand about this. Now, some multiple choice question for you. The runs scored by a batsman in 5 ODIs are 31, 97, 112, 63, and 12. The standard deviation is. So you have to apply this simple calculation which we have already did it. You can calculate the value. So this is the quiz and a multiple choice question for you. When the mean of number is this, okay, 18, what is the mean of sampling distribution? So you have to identify this thing. The error between mean of infinite or finite data is known as the undesirable characteristic of measuring system. You have to identify. Find the mean of tossing four coins. Find the mean of tossing four coins. Okay. So you have to take head, tail, head, whatever it is. So you have to calculate. If you have any query, you can ask me. Then another MCQ, standard error of mean is calculated by standard error is statistical measure of error is, because we are talking about the error. So error is uncertainty in measurement. It is true statement or false. You have to just find out which what is the value you have. Magnitude of error can be negative or positive. Find the approximate value of 1.404. Okay, so these are some multiple choice question related to your topic. Now these are the references. As I earlier told you in my previous lecture, we basically refer some books, good books. First is the Rajesh Prasad Khanna publisher, Amazing Instrument. Second is A.S. Morris, international author. You can say it is a good book of principles of measurement and instrumentation by Prentice Hall. So I hope you understand about the standard deviation, because we talked about the standard deviation here in this lecture. So I hope you understand in this lecture how can we calculate the errors, group of errors, by using standard deviation method. So standard deviation method is good to calculate the dispersion basically. So I hope you understand this thing, and if you have any query you can ask me. So it is all about from my side in this lecture. Thank you for listening.